Today we're going to be looking at two-way frequency tables. So our objective says I can summarize categorical data for two categories using a two-way frequency table and recognize possible associations and trends in the data. So we have this word here, categorical data. I want you guys to take a few seconds, maybe a minute or so, talk to your partner. What do you guys think categorical data, what does that mean? Like, what are categories? Just in general, look at different examples you can think of. What are categories that can be categorical data? So categories, good. You guys came up with good examples. We have different types of music, food, sports, basically stuff that categorizes data, basically, right? So that's exactly what we're going to be going over today, is categorical data. So categorical data is data that cannot be expressed using numbers. That's called descriptive data. So for example, such as type of animal, model of a car, favorite song, there's no numbers attached to those types of data, right? So this here cannot be expressed using numbers. So like color, blue, orange, green. You have animals, dogs, cats, other pets. You have music like country, pop, rock, rap, different types of things. But notice I haven't said anything about numbers, right? So categorical data cannot be expressed using numbers. So looking at these 4 examples down here, take a look at all 4 of them and then try to figure out which one would be an example of a categorical data, something that is not attached to numbers. Categorical. This is non-numerical. Okay. Go ahead and write it. Tell your partner, what do you think? Which of the 4 is categorical? Okay. I kind of heard like this side over here. What about over here, this side? Which one is categorical? Color, right? Color, because we have like red, orange, blue. None of those have to do with numbers, right? But if we look at temperature, we can have like 76 degrees, 80 degrees, and so forth. What about weight? Weight, I can have like 150 pounds, 200 pounds. Height, people can be in inches or in feet. We can say like 70 inches. We could say 5 foot 6 inches. Those all have to do with numbers, right? So these 3 examples right here are actually called quantitative data. Quantitative, because they have to do with numbers. So these are numerical data. Okay, quantitative, quantities. I can attach a number to it. So this is a numerical data. It's called quantitative. Okay. Color, for example, here, this one though, color, this is categorical because the data has no numbers attached to it. Like red, orange, blue, those are not numbers, those are categories, right? So that's the difference between quantitative and categorical. Quantitative is numerical. Categorical, we don't have any numbers attached to them, okay? So checking for understanding, I want you guys to see this one here. Identify whether each given data is categorical or quantitative. So again, categorical is non-numeric. There's no numbers attached to it. And quantitative is numerical. So look at the two examples at the bottom. Describe which one is categorical, which one is quantitative. So large, medium, small. I don't have any numbers attached to them. Quantitative, I have 120, 130, 40 feet squared. Those are all numbers, so it's quantitative. Okay, good. All right. Now let's talk about what's a frequency table. A frequency table shows how often each item occurs in a set of categorical data. So now we're going to attach a frequency, which, yes, that's a number, but the actual category is not a number. But now a frequency table, frequency basically means how often something occurs, okay? So in this example, it says, use the categorical data listed on the left to complete the frequency table. So my data here says, this is the ways students get to school. So I can see bus shows up 1, 2, 3, 4, 5, 6, 7, 8. So 8 students take the bus to school. Then if I look at car shows up 1, 2, 3, 4, 5, 6, 7. So 7 students take a car to school. Okay. And then my last option that I see on the table is walking. I have walk, walk. So 3, 4, 5 students walk to school. 5 students walk to school. So now I have my frequency table filled in. I can see 8 students take the bus to school, 7 students take a car to school, and then 5 students walk to school. So the frequency is how often something occurs, okay? This is how often something occurs. So 8 students take the bus, 7 students take a car, 5 students walk to school. So the 8, 7, and 5 is the frequency, how often something happens. Okay, this is just a one data though. Sometimes we'll have 2 data sets. So if we have 2 data sets to compare, it says the data set has 2 categorical variables. You can list the frequencies of the paired values in a two-way frequency table. So for example, here I have a survey of 9th and 10th grade students was done, asking which type of fruit they preferred. So I'm asking like their grade level, and I'm asking their favorite type of fruit. Both of those are categorical. 9th and 10th grade, even though it's a 9 and a 10, that's not necessarily a number attached to it. It's just a grade level, so that's still a category. And then which type of fruit they preferred is also categorical, okay? So this is called a two-way frequency table, because I can see grade level on one column, and then the preferred fruit is my other variable here, okay? So to read the table, I can see the total for apple goes downwards, the total for orange is also vertical, and banana goes vertical. The grade level, freshmen go horizontal this way, and then sophomores are horizontal this way, okay? So to complete the table, the total for each column goes at the bottom. So to get the total, you just basically add 19 plus 22 to get that total. So 19 plus 22, that's going to be 41. And then if I add 12 plus 9, what is 12 plus 9? 9 plus 2 is 11, so that's going to be 21. And then if I add 23 plus 15, what is that? 38. So the columns, you add them vertically, top to bottom, okay? The rows, to get the totals for the 9th and 10th graders, you add horizontally. So this time you go this direction. We're going to add 19 plus 12 plus 23. 50, 54? Yes? Okay. And then if you add the 10th grade students, you go this direction for 10th graders. So 46, thank you. So 54 ninth graders and 46 10th graders. So to get the total for the grade levels, you add horizontally. The total for the fruit, you add vertically. And then notice I have an extra box left over. I have this extra box right here in the corner. This extra box is for the grand total. How many total students were surveyed? This is grand total. And how did you get 100? Good. You add 54 plus 46, and that's going to give you 100. And another thing is horizontally, all of these totals for fruit also has to add up to 100. Okay? So on a two-way frequency table, you always add vertically and you add horizontally. And then the grand total has to equal both the total for the first variable and the total for the second variable. Okay? So now that our table is complete, we have to answer these questions down here. It says, was the survey evenly distributed between 9th and 10th grade students? So if I look at the total for 9th graders, I have 54 students. And for 10th graders, we have 46. So is that even? Are they evenly distributed? No. I have more of which grade level were asked. 9th graders. So we're going to say no. There were more 10th graders more 9th grade students that were surveyed than 10th graders. Okay, so no, it's not evenly distributed because I can see 54 9th graders were asked compared to like the 46 10th grade students. So more 9th grade students than 10th grade students surveyed. Okay, and then the last question says, which type of fruit was least preferred? And we're supposed to justify your answer. So if we look at the fruit totals are now 41, 21, and 38. I'm not sure what happened there, but we have 41, 21, and 38. So which of these is the least preferred? Oranges. I have only 21 students preferred orange, 41 for apple, and 38 for banana. So we were going to say oranges was the least preferred fruit because more students preferred apples or bananas. Yes? Our next example says here we have 100 students were surveyed about which beverage they chose at lunch, and then some of the results are shown in a two-way frequency table. We have to complete the table. So I can see the table is separated by gender. We have girls and boys, and then this is the beverage that they chose during lunchtime. Okay, Notice I have some gaps in my table this time. In between, I have gaps. So in the table, I know that the we add vertically, and then this grand total has to be these together and these together, right? But on the actual context here, it tells me I have a total of 100 students. So I know that's going to be my grand total is 100. So this right here is the grand total. So this box is always our grand total. So on my survey, it says I had a total of 100 students. So I know I plug in 100 in that box. And then to calculate this data, if my total has to be 100, I have a total of 60 boys. That means how many girls had to be surveyed? 40. And how do you get 40? What operation did you do? Subtraction. We do 100 minus 60. That gives us our 40, right? Okay, for the total juice, what operation do we do going downwards? Addition. So 10 plus 15 gives you what? 25. And then can I add here to get the next total? I don't know what that milk for girls is. I have to figure out how many girls preferred milk during lunchtime. How can we calculate that? 17 plus 10. Oh, okay. You can do, okay, so you're doing this. 17 plus 21 gives you 38. And then what? Okay, good. So you are actually calculating this one right now. But basically, I can do the same thing you're thinking for girls. Do 40 minus 10 minus 17. Or you can do like Alondra is doing, 25 plus 38, and then subtract 100. That gives you this total. And then take this minus 24 to get you that one. Whatever you do, it's fine as long as you get both answers. Okay? So for this box right here, you can take 10 plus 17 gives you the 27. We're going to do 40 minus the 27 to get that box right there. It's going to give you what? 13, right? And then now I can add 13 plus 24 to give me 37, okay? You could have done the other way too, like Alondra was saying, 25 plus 38, then subtract from 100, and that gives you still 37 there. Okay, but the main thing I want you guys to notice is, again, adding, going downwards, and then subtracting, you can go if you're going upwards. If you needed to find a value on top, then you subtract from bottom, okay? All right, then my question here is, how many more boys than girls chose juice? So this one specifically, I'm looking at the juice column, is asking how many more boys than girls chose juice. So if 15 boys liked juice and 10 girls liked juice, how many more boys chose juice? What is it? 5. How do you get 5? How do we get 5? Yes, 15 minus 10 gives you 5. And then my last question for this one says, how many girls chose milk or water? So this one, it says milk or water. So this or means you're going to add the milk and the water for the girls. So the girls that chose milk is 13 and water is 17. So milk or water, you would add those together, 13 plus 17 to give you 30. Okay? All right, awesome. It's just checking for understanding. This is not on your notes anywhere, but I want you guys to kind of just think about the question here. It says, how can categorical data with two categories be summarized? Like, what do we use to organize the data? What is that table called? Good. So I hear Dioman saying this is a two-way frequency table. Okay, good. All right, so we have about 8 minutes or so before you guys clean up. So rest of the period, you guys are going to work on the assignment in class, okay?